According to the 2020 National Electrical Code, specifically Article 392, which pertains to cable trays, Section 392.14 addresses the support of cables. Subsection C focuses on spacing. It states that supports must be spaced to prevent excessive deflection of cables. This means the distance between your J-hooks or other supporting devices should be such that the cables don't sag or droop excessively. The maximum spacing between supports is determined by the cable size. For cables not of a number 10 American wire gauge, the maximum spacing is 12 inches or 305 millimeters. If you are using cables larger than number 10 American wire gauge, the maximum spacing increases to 18 inches or 457 millimeters. There is an exception to this rule. Cable supports may be spaced not more than 36 inches or 914 millimeters apart for pre-assembled cables that are factory attached to cable trays and that are designed to be so supported. This exception applies to specific cable tray systems where the cables are pre-installed and the system is engineered for wider support spacing. To summarize, if you're running individual cables, the 12-inch or 18-inch rule applies depending on the cable size. The 36-inch spacing is only for specialized pre-assembled cable tray systems. It's important to note that the code uses the phrase excessive deflection, and judgment may be required in some situations. Factors like the weight of the cable, the type of insulation, and the ambient temperature can all affect how much a cable deflects. When in doubt, it's always best to err on the side of caution and use more frequent supports. This ensures the cables are properly supported and that the installation meets the intent of the NEC. Always consult the latest edition of the NEC for the most up-to-date requirements and consult with a qualified electrical inspector if you have any questions or concerns about your specific installation. The NEC guidelines ensure safety and longevity of the electrical system by preventing stress in the cables, reducing the risk of insulation damage, and maintaining proper airflow around the conductors. Moreover, proper support spacing contributes to a neat and professional installation, making it easier to troubleshoot and maintain the system in the future. The NEC guidelines are not just suggestions, they are legally enforceable requirements designed to protect people and property from electrical hazards. Failing to comply with these requirements can result in fines, project delays, and even legal liability in the event of an accident. It is recommended to regularly review the NEC and related standards to stay informed of the latest changes and best practices. Firstly, determine the correct support spacing based on the cable size you are using, remembering the 12-inch rule for number 10 American wire gauge and smaller, and the 18-inch rule for larger cables. Secondly, ensure that the supports themselves are properly installed and securely fastened to the building structure. Thirdly, avoid over-tightening cable ties or straps, as this can damage the cable insulation. Fourthly, inspect the installation periodically to ensure that the cables are still properly supported and that there are no signs of excessive deflection or damage. 5. Remember that these spacing requirements are specifically for cable support in ceilings and may not apply to other types of installations. 6. If you are unsure about any aspect of the installation, consult with a qualified electrician or electrical inspector. 7. Always follow all applicable safety precautions when working with the electrical systems. 8. These rules are designed to minimize strain and potential damage to the cables, extending their lifespan and reducing the risk of electrical failures. 9. Understand that proper cable support is an integral part of a safe and reliable electrical system. 10. Regular inspections and maintenance are key to ensuring the continued integrity of the installation. The NEC is a comprehensive document, and it is important to consult the specific sections that apply to your particular situation. Article 392 is just one small part of the NEC, but it highlights the importance of paying attention to detail and following established standards when working with electrical systems. Neglecting cable support spacing can lead to a variety of problems, including cable damage, overheating, and even electrical fires. In addition to the spacing requirements, the NEC also specifies the types of materials that can be used for cable support. These materials must be suitable for the environment in which they are installed and must be able to withstand the weight of the cables. Common materials for cable supports include metal J-hooks, cable ties, and cable trays. The choice of material will depend on the specific application and the type of cables being supported. Metal J-hooks are often used for supporting individual cables, while cable trays are used for supporting multiple cables or bundles of cables. Cable ties are typically used to secure cables to J-hooks or cable trays. When selecting cable ties, it is important to choose a type that is rated for the environment in which they will be used. For example, if the cables are exposed to sunlight, it is important to choose cable ties that are UV resistant. The NEC also addresses the issue of cable fill in cable trays. Cable fill refers to the amount of space occupied by the cables in a cable tray. The NEC limits the amount of cable fill to prevent overheating and to ensure that the cables can be easily accessed for maintenance. The maximum cable fill is typically expressed as a percentage of the cable tray's cross-sectional area. It is important to consult the NEC for the specific cable fill requirements for your cable tray system. In addition to cable fill, the NEC also specifies the minimum bending radius for cables. The bending radius is the minimum radius to which a cable can be bent without damaging the insulation or conductors. The bending radius is typically expressed as a multiple of the cable's diameter. It is important to follow the manufacturer's recommendations for bending radius to avoid damaging the cables. When installing cables, it is important to avoid sharp bends and to ensure that the cables are properly supported throughout their entire length. Sharp bends can create stress points in the cable, which can lead to insulation damage and premature failure. The NEC also addresses the issue of cable separation. Cable separation refers to the distance between different types of cables. The NEC requires that certain types of cables be separated from each other to prevent interference and to reduce the risk of electrical fires. For example, power cables should be separated from communication cables to prevent noise and interference. The NEC also specifies the minimum separation distance between different voltage levels. In general, higher voltage cables should be separated from low voltage cables to reduce the risk of arcing and short circuits. The NEC provides detailed guidelines for cable separation, and it is important to consult the code for the specific requirements that apply to your installation. In addition to the NEC, there may be local codes and regulations that apply to electrical installations. It is important to check with your local building department to ensure that your installation complies with all applicable codes and regulations. Local codes may be more stringent than the NEC, and it is important to be aware of these differences. Compliance with all applicable codes and regulations is essential for ensuring the safety and reliability of your electrical system. It's crucial to remember that this information is based on the 2020 NEC. Electrical codes are updated periodically, so always refer to the latest version of the code for the most accurate and up-to-date information. While this explanation provides a general overview of cable support spacing requirements, it's not a substitute for professional guidance. Always consult with a qualified electrician or electrical inspector for specific advice related to your project. They can assess the unique circumstances of your installation and ensure that it meets all applicable requirements. Moreover, they can help you select the appropriate materials and installation techniques for your specific needs. They can also provide guidance on other aspects of electrical safety, such as grounding and bonding. In addition to the NEC, there are other industry standards and best practices that can help you ensure the safety and reliability of your electrical system. For example, the National Fire Protection Association, or NFPA, publishes a variety of standards related to electrical safety, including NFPA 70E, which covers electrical safety in the workplace. These standards provide valuable information on how to protect yourself and others from electrical hazards. The Institute of Electrical and Electronics Engineers, or IEE, also publishes standards related to electrical engineering, including standards for cable installation and testing. These standards can help you ensure that your cables are installed correctly and that they meet the required performance specifications. By following these standards and best practices, you can help to ensure the safety and reliability of your electrical system. Always prioritize safety when working with electricity. Electricity can be dangerous, and it's important to take all necessary precautions to protect yourself and others from electrical hazards. Before starting any electrical work, be sure to turn off the power at the breaker panel. Use insulated tools and wear appropriate personal protective equipment such as rubber gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Remember, it's always better to be safe than sorry. Electrical safety is not just about preventing injuries, it's also about protecting property from damage. Electrical fires are a leading cause of property damage, and they can be caused by faulty wiring, overloaded circuits, and other electrical hazards. By following the NEC and other safety standards, you can help to reduce the risk of electrical fires and protect your property. In addition to following safety standards, it's also important to maintain your electrical system properly. Regularly inspect your wiring, outlets, and appliances for signs of damage. Replace any damaged components immediately. Avoid overloading circuits, and use surge protectors to protect your electronic equipment from power surges. By taking these steps, you can help to ensure the safety and reliability of your electrical system and protect your property from damage. One final point to consider is the impact of your electrical installation on the environment. When selecting cables and other electrical components, choose products that are energy efficient and environmentally friendly. Dispose of old electrical equipment properly to prevent pollution. By making environmentally responsible choices, you can help to reduce your impact on the planet.